This is the learning objective for this lesson. We're mostly interested now in determining how levels of consumption spending are established and what is this thing called the multiplier effect. So we're going to skip ahead here. There is a model called the aggregate expenditures model, which is not on the AP test, and we're not in general going to explore this model, but a little bit of this model is helpful for understanding the determinants of consumption. So we're really just going to look at that portion of it. So this is our question: what determines the level of consumption spending? And if you pause for a moment and look at this graph, the answer is pretty obvious. It's income, disposable income to be precise, which means after-tax income and after families have received any transfer payments like Social Security spending. If you look at these particular points, you can see a very obvious and direct relationship between income on the x-axis and consumption on the y-axis. And if we draw a line between those, that will help us then make some predictions. For example, we could predict what people would spend if they had no income, which would be a little bit less than that 20,000, or what people would be willing to spend if they had just a little bit more income, right? So we could project points into the future. This word autonomous here refers to this kind of spending. So there is a certain amount of spending we call autonomous, meaning it's not related to the level of income. There's a certain amount of money that people are going to spend whether or not they have any income. So you can imagine, using algebra, looking at this line, that we can pretty easily derive an equation that will explain this line. And the equation here looks a little bit odd perhaps, but it's just saying over here consumption, so the y value is A, autonomous consumption, plus, of course, the slope. So plus the change in y over change in x, and then times y, which is here. Sorry, change in the y-axis over the change in x-axis. So what's a little bit odd about this equation is that we see the intercept, right? And we see the x-axis, which is oddly called y here. But instead of having a slope, we have this, MPC. And MPC is short for marginal propensity to consume. The MPC tells us what is the portion of the next dollar of income that an individual will spend. So it's the change in consumption, or the change in the y value, divided by the change in income, which is our x-axis value. Each time we have a change in income, it results in a change in consumption, and that gives us the shape of the line. So the MPC is a very, very important number because it helps us understand people's decisions. It helps us look at the margin at how people are going to behave if they receive additional income. Similarly, the MPS, or the marginal propensity to save, helps us understand what portion of income will be saved. And fortunately, in this very simplified model, we're only letting people do two things with additional income: consume or save. So if you add together the MPC and the MPS, you're always going to end up with 1. The most significant part of that model, and the aggregate expenditures model, basically builds on that consumption line and adds in other types of spending to see what happens. But the most significant part for us is the concept of the spending multiplier. So this table and understanding the multiplier is very critical. Think about this as if there is an economy with the circular flow diagram, and the income that is being received by consumers is being spent on consumption, being received as income by businesses, paid out to consumers again, and we have this wonderful equilibrium where the dollars being spent are the dollars being earned. And then all of a sudden, from somewhere outside of the economy, comes this foreign direct investment of $5 billion. And we're just going to refer to it as 5 here, to keep the math simple. 5 is suddenly injected into this economy. So that money, that investment, let's say that the person who brings that money in decides to build a new factory. And that spending to build that factory becomes income to people within the economy. So here's where the MPC comes in handy. The MPC tells us, oh, when those people receive that income, they're going to spend 75% of it, or $3.75, and they're going to save 25% of it. But this is where it gets interesting, because this money that these people then spend now in the second round becomes income to more people. So the people who earned money by building the new factory might go spend that money, say, on dance lessons. And when they spend their money, that becomes income to other people, right? So now more people have received a change in income, and the MPC tells us the people who received the second round of spending will now spend 2.81 billion of their additional income, and that becomes income to more people who will then spend, again, 75% of it. So round after round of spending happens. This money is moving around the circular flow diagram. So unfortunately for us, this table kind of cuts off right here, right? And it says all other rounds. Well, how do we know where that came from? Well, there's a couple of ways to know where that came from, and one way is if you understand infinite series in math. And there is a Khan Academy video on the Moodle course site with the mathy explanation. But I'm going to explain it a slightly different way because I know not everybody knows that math. And this is not necessarily simple. Let's start over again with an MPC of 0.8. Okay, so not 0.75, but now we're saying people are going to consume 80%. So an increase in investment will result in a change in income of 100 and a change in new consumption of 80. Remember, 20 is going to be over here. It's going to be saved. And that money becomes spending in round 2. People earn $80 additional income, consume additional 64. Okay, I'm going to challenge you to fill out this chart and keep doing round after round after round where people are consuming 80% of the additional income they receive. And when you add all of this up, you're going to find out something very interesting. And that is that the initial change of 100 becomes 500. So by doing that, we can see, oh, the initial change in 100 becomes 500. And again, I challenge you, if you don't want to do the infinite series explanation, to work this through one time to see it happen. Okay, the multiplier then is obviously 5, right? We can see that. The multiplier here is 5. And the multiplier on the other table, right, the $5 became 20. The multiplier was 4. Well, it's interesting, isn't it? When the MPC is 0.75 and the MPS is 0.25, we have a multiplier of 4, right? But when the MPC is 0.8 and the MPS is 0.2, we have a multiplier of 5. If you look at this, you'll notice that it's both cases, it's 1 divided by the MPS gives us the multiplier, right? 1 over 0.25 gives us 4, 1 over 0.2 gives us 5, and that's always going to be the formula for our multipliers. 1 over the MPS, or 1 over 1 minus the MPC, will be the formula for the multiplier. So pause the video for a minute and see if you can figure out the MPS in each of these situations. The MPS here is 0.1, 0.2, 0.25, 0.33, and notice each time, right? 1 over 0.1 gives us a multiplier of 10. 1 over 0.2, multiplier of 5. 1 over 0.25, multiplier of 4. So all of the ones on this table, you want to know how to calculate them like that, or you want to just memorize them, because these are the only ones, these are the only values you're going to see. We're not going to ask you to do complicated math here. But you need to understand that relationship between the MPC, the MPS, and the multiplier. And again, it's because the amount of money that people consume in each additional round is going to determine the ultimate increase in GDP in the economy. So that's the spending multiplier, or what's called the simple spending multiplier. There are 2 other multipliers that we need to know as well. And before I go into them, just to review for a moment, if the spending multiplier is 4, what we're saying is that an increase in spending or an injection into the economy of $100 million is going to lead to an increase in GDP or an increase in overall spending of $400 million. So the tax multiplier is going to be a little bit different, and I'm going to pause for myself for a minute just to write the formula. So the tax multiplier formula is negative MPC over MPS. And what that means is that if your taxes go down by 100 million, first of all, the negative sign there means that if taxes go down, we expect GDP to go up. So negative just shows that inverse relationship here. So if your taxes go down by 100 million, that means that every household, well, spread across households, there's $100 million in additional income. But that doesn't count toward GDP right away. It doesn't count toward GDP until they spend it. So how much of it will they spend? Well, the MPC tells us that they're only going to spend 75% of it. So the first round of spending becomes Okay, we're going to multiply by 0.75. First round of spending becomes 75 million. And then to know how much total spending will increase, we take that 75 million times 1 over the MPS, right? And we get 300 million. So notice the multiplier is smaller. An increase in spending of 100 million becomes 400 million in GDP, but a tax cut of 100 million becomes 300 million in GDP. And the reason is because the first round of spending doesn't happen until we apply the MPC. So that's why the formula is here. We apply the MPC to find out what the first round is, and then we multiply it by the normal multiplier. So that's why it's MPC over MPS. So after you're done watching the video, you should go back and calculate the tax multiplier for each of the spending multiplier values given. Also, the balanced budget multiplier, and this one's a little bit more complicated. Well, it's simpler in one respect. The balanced budget multiplier is always 1. Understanding why it's 1 is a little bit more complicated. A balanced budget multiplier means that we do something like increase spending by 100 million, okay, and we'll say government spending, and at the same time, we increase taxes. So in other words, we're actually increasing taxes to pay for that, also by 100 million. So the government spending increase gets the simple spending multiplier of 4 and would increase GDP by 400 million. But the tax increase will get a multiplier of negative MPC over MPS, or negative, right, 0.25 over, negative 0.75 over 0.25, which gives us a negative 3. So the taxes will cause GDP to go down by 300 million. And when you add together the impact of the government spending and the impact of the taxes, the net is an increase of 100 million. That's why equal increases in taxes and spending will cause the same magnitude increase in GDP.